Hello all, welcome to AK Apt Logics. In the previous class, we have discussed about the nets and variables, and especially we have discussed about the Y data type, which is uh, related to the net data types. So in this class, we're gonna discuss about the variables. In this class, we're gonna discuss about the variables in detail. The variables uh, is on other hand it is a abstraction of data storage element and can hold values. In the previous class we have seen about the wires that wire can't able to store the value. It just simply transmit the signal from one place to another. It doesn't store any value. It's like a simple wire. Okay, so whereas coming to the variable is the thing uh, which is able to store the values, whereas net is used to transmit the values. Okay, the nets itself can't able to store the value, whereas variable can store the value. That's the difference between variables and net. A flip-flop is a good example for storage element, right? The basic block of the memory element is the flip-flop. Of course there is a latch also, but the basic uh, storage element is flip-flop. Okay. Yeah, coming to the variable types, there are so many types in variables, like general variables like integer and all those types will be there. Those will be discussed will be in the next video. But coming to particular to the Verilog, where in case of nets we have seen about the y, right? Similarly, in the case of variables, we have the data type called reg. Data type called reg. Verilog data type reg can be used to model hardware registers. Reg refers to the hardware registers since it can hold values between assignments. Okay, coming to if you're gonna see about the wire, which is a net data type, it is used to transmit the signal from one place to another. It represents the physical wire or a internal wire or the external output or input wire which can be taken or the given by us the data. The net represents the internal wire, whereas the reg represents the internal storage elements or the external storage elements like the flip-flop or the registers. Okay, so the variable, the first type is reg. Okay, similarly how we have net wire in net data type, we have reg in variables. Okay, so reg means simply hardware register which is used to store the data. Okay, it can hold values between assignments. Note reg need not always represent a flip-flop because it can also be used to represent combinational logic. Okay, reg can also represent combinational logic as well. It doesn't mean it's always represent the flip-flop, but the thing you have to remember is reg can able to store the data, whereas wire can't able to store the data. Okay, and reg is mostly used in always block outputs in the always block should be reg always. All these points will be discussed by me in the while I'm gonna discuss about the always block, whereas for the wire the output should be always uh, wire in data flow model. Okay, in the behavioral model when we use the always, the outputs should be declared as reg. Okay, whereas in the data flow module we have to declare the output as wire. Okay, so all these points will be discussed by me in the further. So let us deeply understand about the reg. What is meant by reg in the pictorial form, the diagrammatic form. Okay, yeah, for a suppose, let me erase this. Yeah, for suppose if we have declared the reg a, if you have declared the reg a, what does it means, so it's simply a flip-flop. Okay, which is capable to store 1 bit. This will be treated as A. It can able to store only 1 bit, either 1 or it may be the 0. Is it okay? It can able to store either 1 or 0, only single bit. Okay. If this is also called as scalar representation. In the previous class while discussing wire we have seen the similar thing, right? This is called the scalar representation. Sorry, my handwriting is so bad. Yeah. So if you want more than 1 bit to store, if the case is for you to store more than 1 bit, then you have to declare in the vector form. Okay, for suppose I am declaring 3 down to 0, 3 down to, you have to spell it like 3 down to 0. Okay, what does it mean is we have total 4 registers, 4 uh, 4 registers. Okay, from this can be treated as from a of 3 and so on up to a of 0. Okay, so this means how we gonna represent this is, so we have a register which is having 4 bits. Okay, the MSB will be treated as a of 3 and the LSB will be treated as a of 0. Okay, remember this point. If you have declared like this 0 down to 3, then MSB will be a of 0. Okay, and LSB will be a of 3. This will be LSB. This will be MSB. Okay, yeah. So and also you can able to use the negative numbers too. Okay, you can also able to declare like this uh, -2 down to uh, -2 down to 0. You can also do like this. Okay, you can use any negative numbers, positive numbers, any numbers. Okay, yeah. So we can access individual registers, okay, separately. Okay, individual registers separately by using the name and its particular index value. For example, if you want a of 3, then you can able to use like this representation a of 3. Okay, if you want a of 3 and a of 2 as well, then you can able to represent like this a of 3 down to 3 down to 2. Okay, if you want 2 and 1, then you can represent like this a of 2 down to 1. Similarly, in the wire case also, we can able to access a single wire. Okay, you can able to access a single wire or 2 wires or all the wires. Okay, for accessing all this register completely, we have to just use the register name. For accessing a single register bit, then you can able to use the a of and its index. For accessing 2 bits anywhere in between the register or in between the register, we have to use this particular representation a of 3 down to 0, 3 down to 2. So a of 3 down to 2 you can only able to use when you declare like this. Okay, when you declare register like this, let me change the pen. When you declare register like this, then only you can able to declare like this. Why? Because if you are going to declare like this, if you want the 2 and 3, okay, if you want 2 and 3, then 2 and 3 will becomes it will be become a of 0, right? It will be become a of 0, and the last one will become a of 3. and the before last one will become a of 2, right? When you declare in the form of second format. See, if you declare like this, then you have to use a of 3 down to 2. Okay, why? Because here a of 3, sorry, it will be a of 2, right? Sorry, a of 2 down to 3. Okay, here a of 2 is uh, right side to the left side to the a of 3. It means a of 2 is the most significant bit than a of 2, a of 3, right? a of a of 2 is the most significant bit than a of 3, while in this case, in the first case, a of 3 is the most significant bit than a of 2, right? So you have to use always the most significant bit followed by the other bits to call these particular things. So all these things will be discussed by me again. Okay, this part is called part select. There are two types of selections: part select and bit select. Okay, part select means simply if you want more than one bit, like this in this case. See this case. Okay, this case will be called as part select. Bit select means simply accessing single bit. Okay, to access complete register at a time, we can able to use the a. Okay, and you have to remember the point is always the vector representation, whether it may be in the wire case or the register case, reg case, we have to declare the range of bits left side to the variable. Okay, if you're gonna declare the range after the variable, it will become array. Okay, then you can able to only you can able to only access different bits separately. It means all the bits will not be considered as a single number. Okay, in case of vector, we can able to consider this complete register represents single value. Okay, in case of vector, this complete register represents single value, and also individual bits can be accessed. Okay, both can be done. We can able to access either these two bits, or else you can able to access complete register, or you can able to access individual bits, this bit separately and this bit separately, like this. Okay, so where in case of uh, array, each bit represents separately, and we can't able to use all those separated bits combinedly to represent a single number. Okay, that's the difference between the vector and array. All these things will be discussed by me again. So I'm just giving you some trailer, that's it. In the coming videos I will be discussed. So the thing here you have to understand firstly is the representations of reg in the scalar and the reg in the vector form. I hope you got this, and also how we gonna access these things you should remember. So let us see the code, simple code to demonstrate the reg. Okay, in the previous section, if you're gonna see the points to be remembered. Okay, this is for the case of wire, right? So by default wire can carry single bit. Okay, yeah, by default reg is a single bit. Okay, let us write these points one by one in case of reg. Okay, yeah, this is in the case of wire. In the case of reg, let us write by coding only we can able to write. Okay, by default wire can carry single bit. Okay, how you gonna prove this? How you gonna prove this? By code we have proved in the previous class, right? Now in this case we have to think about the reg, right? So let me perform this. Let me comment this particular thing to write the code. So this is our thing. We have to prove reg carries only single bit in the form of code by the simple code, not just it's not a great code. very long code. See, let me write this program. I'm gonna create. You haven't used the reg as a identifier, right? So uh, a reg a I'm declaring. So I'm gonna declare with some other name, uh, maybe variable. Okay, let me declare variable. Yeah, reg. Let us declare a. Okay, initial begin. So no need to begin. Okay, yeah, let's take initial begin. uh, let us simply print the value. Okay, let us simply print the value. Okay, let us assign some particular value to this, like 2. Okay, so let me print the value a equal to percentile in the form of binary. Let us print. Why? Because reg is used to store the single bit, right? If you're gonna print using percentile 0b, we can able to know how many bits it going to be stored and how many bits it going to be print. Okay, so before executing this program, let us see, right, what is the expected output. Okay, our expected output will be uh, 1 0, right? Isn't it? So actually the output will be here, right? A equal to 1 0. This is our expected output. Let me run this program. So every point you should need to get from the coding only, coding part itself. So I think it's is the thing. Yeah, it's getting running. Yeah, there are no any errors. Let us run the second thing. So if you're gonna see over here, actually we have given 2, right? And our expected output is 1 0. Why? Because in the binary format we represent 2 as 1 0, but we are getting only 0. It means we are getting only LSB, and the next and the next to one to the LSB is being ignored. This is why, because by default reg can only able to store the single bit, so that it is going to store only 0 in A and neglecting the 1, because it is used to store only 1 bit, right? So now what we are gonna do is, uh, let us use the vector representation. Okay, so I'm gonna use 1 down to 0. Okay, 1 down to 0. So let me rerun this program. Now what will be the output? It will be 1 0. See, why? Because we have used two registers, a of 1 and a of 0. Okay, which represent, in a of 1 it will be 1 and a of 0 it will be 0. If you want that, you can also able to print those things as well. So let me print those things as well. So a of 0. Okay, let us see what is the value in a of 0. Percentile 0 p comma a of 0. If you want to access the single bit, you can able to access like this. And what we are going to expect, we are going to expect a of 0 to be 0, and you can also able to print the a of something went wrong. Yeah, then what's okay. Oh my, mm, let me dollar display a of 1 equal to percentile 0 b. Okay, comma a of 1. What we are going to expect, we are going to expect a of 1 to be equal to 1. Okay, so I think something happened. Yeah, okay, so let me save this program and rerun the code. Okay, So there is something error. What's the error? 447. I've used at the end, right? Sorry, there is a character A printed. So let me save this program and run the program. So you can able to see that a of 0 is 1 and a of 0 is 0 and a of 1 is 1. Okay, as we expected. Okay, so let us change this vector representation to the reverse, in the sense what is meant 0 down to 1. So a equal to 2. Okay, I'm just reverse it. Okay, when you gonna reverse this, for suppose we are expecting the same output in the a of 0 and a of 1 as well. So a equal to 1 0, right? So we are if you gonna expect this same output, then you will be the wrong. See, the output will be reversed. See, a of 1 is stored with 1 and a of 0 is stored with 1 and a of 1 is stored with 0. In the previous class, a of 0 is stored with 0 and a of 1 is stored with 1. Okay, this is why, because we have used 0 first and then 1. It means 0 will be treated as MSB. The actual vector representation is MSB colon LSB. Okay, followed by the variable name. This is the actual vector representation for any reg or wire. Okay, and we also have to remember the point is only vector representation is possible with reg and wire only in case of Verilog. Why? Because by both the reg and wire are the single bit data types. Okay, remaining all are not the single bit data types. Okay, so that's why only we have to use vector representation with reg and wire only. Okay, so this is the thing. And if you want to know how many bits we can able to use, then the formula will be MSB minus LSB plus 1, in case if you're gonna use uh, this formula, or else you can simply take this largest number. For example, in the case of 1, actually this formula is not worked. Okay, MSB minus LSB plus 1 is not worked. Yeah, I think it's MSB plus LSB plus 1, I think so. Let me check this. Yeah, okay, no, so the formula will be changed. Okay, when you change this particular index order, the formula will be changed, so don't follow the formula. So if you want to use any other things, you can able to use. So let me, we have cleared this point, right? Regarding it reg, we have clear this point. Okay, reg can only able to store the single bit value by default, and we have used the vector representation in the positive in the reverse order and the normal order. So let us use the negative numbers too. I'm gonna give -1 to -2, a equal to 2. Okay, and I have used, so let me run this program. So if you're gonna see what's happened, yeah, sorry, I have used it here a of 0. We have to change it as well. So I'm gonna print a of -1, a of -2. uh, what happened? Okay, something happened to my VS Code, need to check it. Yeah, if you're gonna rerun the program, you're gonna see that it's working. Okay, so I actually haven't changed the over here, -1, okay, colon equal to, okay, is it -1? Yeah, -2 colon equal to, okay. So you're gonna see this code. Yeah, you can able to see that a of -1 is 1. Why? Because 2 in the 2 MSB is 1, whereas in the reg representation the MSB is -1, so that a of -1 is storing the single bit 1, and whereas a of -2 is storing single bit 0. Okay, and we have discussed about this thing. By default reg can be carry only single bit. Let us see this second point. By default reg value, so let me just a second. Yeah, by default reg value, so let me, by default reg value is, so in the case of wire it will be ched, right, which is high impedance or the non-connecting or the no connection. Okay, so in case of reg, let's see. So I'm gonna not assigning any value to the reg, okay, and using simply display statement to print it. I haven't assigned any value to the reg. Okay, reg a, okay, let me run this program. So I'm gonna run this program. So you can able to find the a equal to x. It means by this we can able to say that by default reg can store x. By default reg value is x. Okay, this is the point. And the third point is by default reg is signed or unsigned. Okay, let's see this too. This is also, so I'm gonna take the vector 3 down to 0. Okay, and I'm gonna store -7. Okay, so let us print in form of decimal. Okay, if we don't know, right, uh, whether reg is the signed or unsigned, so let us write a note here. If reg is signed, okay, then we should get result as -7, or else we should get how much. We have used the 4 bits, right? For 4 bits maximum value that we can able to represent in the maximum number of values that we can able to represent is 16, right? We have used 4 bits, max value will be 2 power 4, that will be 16. Okay, we have to subtract the number which we have assigned from the 16, right? So 16 minus 7 will be, then 16 minus 7 will be how much? 9. This is our expected output, right? If the reg is unsigned, if reg is signed, then we should get result as -7, or else if uh, reg is unsigned. Okay, so let's see, by running this program something happened. Yeah, there are errors. There is an error. -442. Okay, I haven't declared the, I have done a proper very blunder mistake. That is, we have to specify the how many bits we are going to use, right? By declaring the negative numbers we have to specify that, right? So for tick D, okay, for tick D, I'm gonna represent it and printing this. No, there is something else. What else? Let me I haven't declared the variable. Yeah, let's simply leave it and see what happens. I haven't declared the variable. Okay, yeah, you can able to see that we got the result as a equal to 9. It means from this we can able to say that reg is a signed. Unsigned, reg is unsigned. Okay, if we didn't get the -7, right? If we get the -7, then we can able to treat the reg as a sign, but we haven't get -7. Instead we get a equal to 9. So let us put the modifier over here, signed, and see what output we are gonna get. So we are expecting the -7, right? So something went wrong. What's the thing? In the previous class I have already told you that you shouldn't mention the modifier first. You have to mention the data type followed by the, so let me, followed by the modifier. In this case the modifier is signed. Let me save this program and rerun this program. Yeah, there are no any errors. So you can able to find the a equal to -7. Okay, yeah. So this is everything about the reg. So I'm gonna write these points to be remembered down. So let me write. Okay, yeah, I'm gonna comment this. Why? Because if we shouldn't use the nested comments. So this is everything about today's class. In the next class we gonna discuss about the some other data types. So thank you guys, and share this video, like this video, and subscribe, and please comment. Your suggestions is always matter to me.